So let's go ahead and let's take a look at oxidation states and reduction reactions. This is covering section 20.1. So what we need to understand is that oxidation and reduction, they occur simultaneously. Okay, so something needs to be being oxidized and something needs to be being reduced in order for these reactions to actually happen. So something has to give up electrons, something has to gain electrons. So when something is oxidized, we refer to it as being a loss of electrons. So something has lost electrons. So if my sodium ion loses an electron, it's going to become Na plus 1 electron. Okay, and this is kind of a look at the half reaction. Okay, same thing. If something's reduced, okay, it's gained electrons, so it's become more negative. So we look at fluorine, right? Okay, F minus, it's gained an electron, so we would have 1 electron on this left-hand side. Okay, so a way to remember this in terms of oxidation and reductions, loss of electron is oxidation, so the Leo says GR. Okay, so loss of electrons, oxidation, gain of electrons, reduction. Okay, Leo says GR. So that's one mnemonic you can utilize. The other one that people commonly like to use is oil rig. Oxidation is loss, is the oil. Reduction is gain. So whichever one of these works for you, I would suggest having it in the back of your head, just because sometimes it can get a little bit confusing. Reduction reactions, or reduction oxidation reactions, otherwise known as redox reactions, are electron transfer reactions. So what that means is something gains electrons, something loses electrons. And the half reactions that you see here, so basically just the oxidation or just the reduction portion of an equation, is how we're going to initially deal with these electron transfer reactions. So if we look here at this example, we have magnesium, okay, which is in its 0 oxidation state, right? And it's going from the 0 oxidation state, so a metal state, right, to its +2 charged oxidation state. So what has happened here is this this magnesium has gone from a 0 oxidation state to a +2 oxidation state. So it has lost electrons. Notice the electrons here are being shown as being lost. Okay, the oxygen here that we have right there, it's one of the diatomics, and so it's in its natural state, so the oxidation state is 0. Notice over here we have an anion, we have the 2- anion. Okay, so the oxygen went from having a 0 oxidation state to a -2 oxidation state. It has become reduced, so we know that we've gained electrons. So reduction has occurred here. And what you guys should notice is that if we put these two together, okay, as you see here, notice that you have your reactants, okay, and then you have your subsequent new products. But you also have your electrons. What you need is to notice about the electrons is the number of electrons gained and lost have to be equal. So they're going to have to be able to cancel out. And we're going to look a little bit more at this very soon here. But for right now, what we need to understand is that we're going to be able to write oxidation and reduction half reactions. Okay, and notice that on the oxidation half reactions, we have something losing electrons and becoming more positive. And on the reduction half reactions, we have something gaining electrons and becoming more negative. We actually see this physically manifest when we read about examples. Okay, so right here we have a zinc bar, so zinc metal, Zn, as we'd write it here. Okay, this zinc metal is in a solution of copper sulfate. Okay, and we've looked at the activity series and we know how this works. We're all somewhat familiar with it, or at least we should be. So we know that these two are together in solution. And what ends up happening is because of the cell potentials, or excuse me, rather the potential for oxidation and reduction to occur, we actually have an exchange here. So what ends up happening is the electrons from the zinc ion get passed to the copper ions floating in solution and subsequently reduce the copper 2 plus ions, and you end up with this nice, beautiful reddish copper setup that starts to form on the zinc bar. In the meanwhile, what you need to realize is that those zinc 2 plus ions are now what starts to float in solution. Okay, and we have another example over here, something similar happening, okay, with our gold and copper. And once again, it follows the same trend. So there's actually going to be a physical response or physical manifestation of these transfers sometimes. So we're actually going to see color changes or physical growth on pieces of equipment that are submerged in solution. So some more vocabulary. So we talked about the oxidized and reduced components. So something that's oxidized has become more positive. It's lost its electrons. Something that has been reduced has gained electrons, so it's become more negative. Now, oxidizing and reducing agents, these are the things that are doing whatever function we're talking about. So, the reducing agent, okay, is the thing that gets oxidized, right? So the thing that's giving up electrons is becoming more positive, yeah? So zinc, right, it's the reducing agent. It's starting out with an oxidizing agent, or oxidation number of 0. Well, it's going to zinc 2 plus 2 electrons. Okay, so we know that the reducing agent is the substance that's going to become more positive. Why? Because it's giving something up. The oxidizing agent, on the other hand, is going to be a item that's going to become more negative. So in this case, we have H+. We'll need 2 of them. And what's going to happen is it's going to pick up the electrons that the zinc is letting off, and it's going to give us H2, right, with a 0 oxidation state. So once again, we're going from +1 to 0. We've been reduced. The hydrogen is reduced because it's accepted those electrons from the reducing agent. So we have reducing agents, we have oxidizing agents. These are all vocabulary words that you need to be very familiar with and be comfortable accounting for. Now, so let's go ahead and let's look at how we would do some of these problems in terms of identifying what's what. So what you're going to do here initially is you're going to have potentially a nice, beautiful equation. Okay, and if we look at it here, we can assign oxidation numbers to everything that's involved here. So that's the first thing you're going to want to do because it's going to allow you to actually establish what goes in each of the half reactions. Okay, so we know zinc solid here is in its 0 oxidation state. Sulfate, we know that it's SO4 2 minus. Okay, and since it's SO4 2 minus, we know that the copper here has to have a +2 charge. Okay. Excuse my handwriting, so +2 charge. If we go over here to the right-hand side, once again we have sulfate, so we know it has a SO4 2 minus, so the zinc now over here has to have a +2 charge. And this copper, notice, is in its elemental state, so it has a 0. So what we're then going to do is we're going to identify what got oxidized and what got reduced. Okay, so if we look at zinc on this left-hand side, and we go over and we look at how it looks on the left, on the right-hand side, okay, you notice that zinc went from 0 to +2. So it's been oxidized, right? Okay, on this other hand, if we look at the copper, and we go here, it's gone from +2 to 0. So it's been reduced. Okay, so then what we're going to do is we're going to take those two items and we're going to break them into their corresponding pieces. Okay, so we said that zinc is oxidized. So we're going to write the formula or the elemental symbol for zinc, and we're going to show the products that get produced from zinc's oxidation. So being oxidized means that you lose electrons, okay, and the number of electrons that it lost has to be balanced with the new oxidation state that it has. Okay, we're going to do the same thing for copper. We started with a copper 2 plus ion. It gained 2 electrons from the zinc up above, and it's subsequently going to give us our Cu solid. So now that we've seen this and we've established what our two half reactions are, we can also identify what the reducing and oxidizing agents. So remember that the reducing agent is a thing that gets oxidized. Okay, so if zinc is oxidized, then it's the reducing agent. Same thing, or same idea with the oxidizing agent. It gets reduced. Okay, so copper goes from Cu2 plus to Cu0. There's definitely a reduction there. So it is the reducing agent. So there's more examples down here below. Okay, you would write the chemical equation out, make sure it's nice and balanced and beautiful, and then you would once again write the half reactions based on first your identification of the oxidation numbers of each element present. Okay, and then you figure out what got oxidized and what got reduced, and then you can subsequently assign oxidizing and reducing agent nomenclature.